Hello, everyone. Let's wait for 30 seconds for 1 minute while participants are joining the webinar, and then we will start. Okay. Hello, everyone, and welcome to our webinar on composable commerce and clean data architecture that scale for complex enterprise. I am Oleg Zhuk, Virto Commerce CTO, and I will be facilitating our discussion today. We are joined by expert Sasha, Virto Commerce founder and CEO, Stefan, Senior Product Manager at Innovadis, and Jacobi, VP of Technology Strategy at Luminos Labs. Today, we will explore why composable architecture aren't just a trend, but fundamental principle for building a scalable and flexible enterprise system. And you can see on the slide in the first section, we will briefly touch on is before it. Then we will move on yesterday, the IT and e-commerce era, where those principles become digital. And the primary, it's well known for us. And finally, we arrive at today AI era, where this moment and new technologies brings new possibility, but also it presents and brings us complexity, new challenges, and we need to somehow to resolve it. The format will be a combination of presentation, discussions, and Q&A, so you are welcome to submit your question in Zoom anytime. And after the webinar, you will be able to see the presentation and recording. And of course, you can contact us on the LinkedIn. Let's start back and a few words about before IT existed and say that composable is not a marketing term. It's fundamental method for managing complexity that existed for centuries. You can think of the assembling the computer from CPU, monitor, keyboard, all independent, but then you can assemble in one computer and start to use it. Jacobi, just a question to you. How do you explain to somebody that composability is more than just marketing buzzword?
Good question, Oleg. To do that, let's kind of look at some slides here. So before we get too deep into technical architectures and AI, let's rewind a little bit on the timeline. So this may come as a shocker, but composability isn't really a new invention. We tend to borrow it from people who built things that do fall out of the sky if you do get it wrong. A plane is a good example. So if we look at this diagram, every component here has a clear job, a known boundary, and someone or some company is accountable for it. And these are just major parts of the diagram. There's certainly thousands of other parts inside of an airplane. But with an airplane, nobody's really debating who owns the wing or who's responsible for the landing gear. If one system fails, the plane doesn't instantly turn into a lawn dart. There's usually fail-safes and resiliency in place. So that's really what composability is boundaries, purpose, accountability, and resiliency in terms of principles. So we've always managed complexity this way as humans. Look back to the pyramids, aqueducts, the power grid, etc. All those have composable kinds of architectures and principles behind them. We break cities into districts, for example, as well. So but in this very era that Oleg, you mentioned today, the AI era, we're certainly not introducing anything new here. We're just bringing it back to what engineers already knew centuries ago. Though you survive the complexity through discipline and not really wishful thinking, sometimes as marketing may put it or seem like it is. So let's take a look at the next slide here.
Mm-hmm.
So this is when all the hard work in the physical engineering world with composability didn't quite translate to digital. So in the physical world, interfaces are obvious: bolts, wires, tolerances, things that are literally didn't fit together unless they were designed to. Okay, very tangible things. Then we went to the digital sides. Interfaces turned into data. Data is an intangible thing. It's fragile, it has integrity issues. It's very hard to touch it, for example. So suddenly everything could connect, and that means everything really did connect, and whether it made sense or not. So just because you can do something doesn't mean you always should. And with that data, we needed ownership, but ownership got really fuzzy really quickly, and teams got bigger, silos started to form, and then we started losing track of who owned what in the software world. Much easier in the physical world with an airplane. And ultimately, what happened, as we'll see in the next era, is that companies started to centralize it to the IT function because it kind of falls down the OSI model, so to speak. And it felt efficient. What ended up happening, though, is that generally that efficiency came at a cost. We ended up losing a lot of the clarity that made composability in the physical world operate. And if you're not familiar, Conway's law explains it pretty well, as you see in the diagram. Your software
Mhm.
will always look like your org chart if you don't do something about it. And if that, when you do that, you've got one big, massive entangled team, you'll end up with one big, massive entangled system. It's not always a bad thing. In fact, that's a good way to start, but it does have really constraints to it. Go ahead, Oleg. Next slide. Okay, and then this is where the good intentions we all had as technical people and engineers started to break things. You know, we chased efficiency, we consolidated, we standardized, we centralized, and for a while it looked really good when everything connected. But then eventually you have the whole like, my gosh, what have we done scenario? And it's not something like you say from a Monday to a Tuesday. It's something you kind of feel over the course of time. And suddenly those small changes you're trying to make as a team with a delicate system suddenly have massive ripple effects. Accountability tend to go up the org chart to higher level people versus going out to where the work actually happened. Okay. Conceptually, I'm sure all of us on this webinar have felt this in some way, shape, or form, where that little peg there you see on the diagram holding things up, some guy named Randy who's about to retire is holding the system up, right? Of
Yeah.
some cron job he operates. And that's how we ended up with systems like you see on the one on the right. It's certainly an exaggeration, but we've all been a part of it in some way, shape, or form. Okay, this is where my artistic abilities certainly have shined on the diagram. And this is the punchline, is that as humans, we've always been really good at building complex systems, but we're pretty bad at maintaining them once boundaries become invisible. And that's where data really applied. So subtly, this happened as bolts and pipes turned to APIs and data, and the things holding it all together stopped being something you could touch or turn or loosen or tighten, and became something you couldn't touch or feel. And over time, our technical capabilities with faster processes, bigger platforms, smarter tools went up. This is a terrible chart that I made because it should be an exponential curve, not a straight curve when it comes to technical breakthroughs. But what happened
Mhm.
at the same time is our organizational discipline, the thing that made Composable work in the first place, um, didn't go along with it. It actually dropped. So we were advancing technically, but regressing operationally as people. And then those two lines crossed, and that's where systems started to outgrow their ability to manage them. And it's like we kept, if I'm going to use the airplane analogy again, it's like we kept building faster engines, but we forgot to rebuild the brakes as we went along at the same time. And that's where the friction started to carry into the IT and e-commerce era, where everything became digital, distributed, and dangerously dependent on each other.
Yeah, thank you, Jacobi. And let me repeat your words. When you're talking about composability, it's a fundamental method for manage complexity on different layers, right? Sasha, let me pass word to you. Why you see composability matter for e-commerce, especially for B2B? How do you see it?
Well, just like Jacobi said, we don't do very well with complexity. So we have to break it down to manageable parts. And composability allows us to do. And as we know, B2B e-commerce solutions tend to be quite complex. And they also tend to be become a core business that actually quite critical to the success of the business. And there are quite a lot of changes that happen to the business that require changes to those solutions. And if those solutions become kind of this monolith that you can't change, or only one person, as Jacobi said, knows how to change them, they become very hard to manage, and that inflexibility becomes critical. So composable in the way of e-commerce, it becomes irreplaceable part. It has to be done that way. Otherwise, you're going to lose, your business is going to suffer. It's okay to start, for instance, for a small project with monoliths at the beginning, but it is extremely important to be able to change those monoliths, to unplug the parts, to decompose the solution and compose it with features that actually fit your new business model or whatever the changed market is. So that's the kind of the major thing, is that e-commerce solutions tend to consist of a lot of different subsystems. Once it actually grows in complexity, includes ERPs, PIMs, OMSs, CMSs, payment systems, and so on. And you have to be able to interchange them, modify them, replace them, and so on.
Yeah, Sasha,
Go ahead, Oleg.
you highlighted a very interesting point about the solution is growing and etc. But maybe it's a tricky question to you. Is it composable commerce only for large enterprise, or you see another implementation for it? Where composable works properly, where not? How do you see it?
I mean, it tend to be if you start with a composable architecture from the beginning, then you do need to have a pretty large organization to basically implement it. If you start with the end goal of being this ideal composable architecture with best of breed applications for everything. But typically what we see is that organizations don't need to have all those systems at the beginning. They don't need the very complicated pricing engine, loyalty engine, or maybe even complicated CMS system. What you can start with is, for example, with Virto Commerce, you can kind of get all in one. You have good enough pricing engine, you have good enough CMS, you have good enough PIM system, OMS, and then you see where you need to introduce some more advanced tools. For instance, if you need some kind of loyalty system or pricing engine that is very sophisticated, maybe specific to your industry, you can remove that piece from Virto Commerce and actually replace it at the later stage with whatever best of breed or whatever is typical in your industry. So that allows you to start very fast, but then still remain agile and replace those features. So for a small organization, it's also quite important to utilize the platform that supports that decomposability, composability principles.
Yeah, Sasha, let me maybe show the slide, and maybe could you say a few words about how you design it and architect Virto Commerce? Because I think it was designed when composable, it was just a term, maybe marketing term. So let me explain what is the schema and what was here in your mind.
Just like you said, the composability wasn't really a mainstream word of the time when we actually designed the Virto Commerce. So you see here, but we followed the same principles of how you actually solve the complexity. How do you solve this complex system? We knew that we're gonna encounter situations where our product management will not fit the need of the customer, or our order management will not fit, or we'll have a different tax provider, or whatever it is. We knew we had to build into the system that resiliency where we can replace the components. And it has to do sometimes with the new technology coming out, like AI, or it has to do with some new vendors coming up with new innovative ideas or solutions that we need to incorporate it. So we design it not only a composable on kind of application levels where you can plug in OMS or catalog system, but we, as you'll see in this graphic, it's composable on 4 levels, basically coming from this atoms, molecules to cells to organisms, and we call it atomic architecture. And we have a very kind of deep guide on how it actually works, but that's the core of the Virto Commerce that allows us to stay this future-proof solution. Basically, we can evolve and replace elements as we see fit. So if the new AI tool or AI capability comes in, we can actually replace it in our system quite easily.
Yeah, thank you, Sasha. Stefan, so we are talking about the platform, but what about implementation partners, right? So what about you? If you work directly with the customer and implement multiple client projects, what's your vision of the composability in e-commerce? Is it help you or not? Let me maybe switch to the next slide and pass word to you. How you see it?
Yeah, thank you very much,
From
Oleg.
your side.
Yeah, thank you very much. Yeah, from our perspective, we made a choice 7 years ago to proceed with our customers in composable commerce. We chose Virto Commerce during that time as our technological partner, especially because of their modular architecture, which Sasha just showed on the screen. But it did not only change our technology stack, it transformed really the way how we are working. As Innovadis, choosing composable commerce, we evolved from project-centric to more ecosystem thinking, not delivering one-off implementations, but focusing on a mindset of reusability, scalability, and continual improvement capabilities. This shift, what we did, unlocked for us speed, consistency, and long-term value. Instead of starting from scratch with every customer, we assemble proven components within our stack, refine them with every implementation, making them better, and deliver solutions that grow stronger over time. And in these 7 years, we're looking at it as an ecosystem mindset. So that means that an ecosystem, you have to recognize that your organization does not operate as a closed system. Your operation thrives on connections, human connections, system connections, data connections. And in a compositive landscape, value isn't created by a single platform or a single team, but our experience is it's created by a network or modular capabilities that work together and, of course, evolve over time. Important shiftings are from ownership, owning everything, to orchestrating the best. That's a very important one. You can pick the best of breed applications from the available tool set in the world and connect them within your commercial platform. From very static roadmaps, you go much more to rapid experimentation. So you can test things, deliver things, see if things work. And especially we're going from isolated systems to living ecosystems. With this mindset, you intentionally design your architectural, your processes, and your teams to collaborate, integrate, and innovate. And you choose tools that complement each other, tools that have purpose. Every part in the ecosystem has to be modular, interoperable, and composable on every level. So with different levels, I mean from the infrastructure to the code base to the user experience. And every part needs to have a purpose within the system. That's most important, also if you look to the data. So maybe you can go to the next slide, Oleg.
Yeah.
So especially in a world where customer expectations evolve overnight, B2B commerce and commerce especially evolves very quickly. Composable commerce delivers the agility, modern architecture that it needs. And every component within that area, you can talk about product management, ERP, checkouts, pricing, search, promotions, CMS, introduction of AI, very important. You can choose them. You have multiple vendors, multiple suppliers. Within composable commerce, it's the goal to replace and definitely not to rebuild. And its core, what we also see with our customers, is that it enables 3 primary outcomes. First of all, the innovation at speed. You can quickly launch new features, you can adopt new channels and add experience without re-platforming or rewriting the areas within your application platform. Secondly, very important is that it's scalability by design. You can scale individual services as demand grows instead of scaling the entire platform. If your search indexes need to scale because of large usage, you can scale that component. If your CMS needs more users, more awareness, you can scale that component. It's not one slider that completely determines the size of your application landscape. But most important, at least for us and our customers, because we want to provide them with options, same as Sasha said before, Virto is very strong in what they have in their core. And also in the image that I put here, you see in the core, you have orders, marketing, cards, pricing, all kinds of best of breed applications that work out of the box. But the real challenge, of course, is getting these applications integrated in your application landscape. Thinking in a composable way makes it a lot easier, because you can extend by deploying your own module, replacing the module. So resilience and freedom are very important. Swap components at any time, future-proofing the architecture and keeping the control at least in your own hands. Maybe go to the last slide. Yeah, because then we come to data. And we talked about techniques, we talked about modules, different systems, you can connect everything. But the glue between all those systems is your data. Composable architectures rely on independent and replaceable services. So data needs to be standardized and consistent to ensure that these services can interact streamly without tight coupling. So data formats are designed to keep systems working with each other, not integrating them end to end so they really know each other. So a tight coupling is important. And what enables that? Through plug and play, clean, well-structured data models that allow teams to swap or upgrade components, for example, your PIM or your ERP, especially without rewriting entire integrations. You talk about the data, you talk about the module, how they should interact with each other. We're not talking about implementations or rewriting complete areas of the composable system. When you have a lot of data, which is important, for example, customer or product data, composable setups often unify data from multiple sources. So when data is consistent and accessible, teams can deliver personal and omni-channel experience from a single point of truth. For example, combining customer data and product data can provide a customer with a personalized proposition, how they go through the catalog when you're talking about a B2B commerce system. And it also reduces integration complexity. Shared data contracts and modules minimize custom mappings, reduce duplication, and lower maintenance costs across the complete stack, because everything tries to talk the same standardized language. At the end, it improves scalability and performance. Composable systems scale best when data is decoupled. Caching, indexing, data services, they all can scale independently from business logic, which ensures fast response times. So not everything has to be taken in account when you want to go to scalability. Also, very hot topic lately is, of course, governance and compliance. When you centralize and standardize your data within your composable architecture, it makes it easier to apply certain regulations like GDPR, access control, audit trails, and enterprise government frameworks, which could be different for different countries of different areas where you are in the world. Support analytics and decision-making. These types of architectures empower organizations to aggregate and analyze and act on the data across the multiple modules that you have, which could result in better insights and much faster adaptation of new technologies, because you see opportunities. And most important, maybe enhanced future proofing and innovation. With clean, structured data, businesses can quickly adapt to new capabilities. For example, AI, new channels, new apps, upgrade without restructuring your complete application landscape or your backend. So data is the key when you're talking about composable architecture, and composable architecture must be seen as an ecosystem that's going through the complete organization and needs to be composable at every level. That's the kind of hypothesis how we're looking at it with our customers. So, Oleg.
Yeah, thank you, Stefan. Jacobi, so what is your visions from Luminos Lab point of view, implementation of the e-commerce solutions from the client point of view? What kind of benefits you see it? So let me share your slide and please present it.
So if we're to think about the timeline again, and we're at the IT and e-commerce area we're talking about, this is where things started to get better, I would say. We realized that composability wasn't necessarily like an architecture diagram necessarily. It was a way to make change survivable, maintainable, and as Stefan mentioned, innovation based. And through it, we unlocked a new capability, which is decomposability, which isn't just adding two letters at the beginning of the same word. It means we can finally replace weak systems without taking everything down. You know, that little block I showed with a guy named Randy holding it all up, we could actually replace that now and not have the whole stack of Jenga blocks fall over, which is great. It's a very empowering feeling. We can retire systems that have been collecting dust without panic. Um, and as Stefan also mentioned, from a business architecture perspective, we can respond to what the business or customer needs are instead of apologizing for what IT can't change. Okay. And that's a very subtle thing that happens, but something that's very important inside businesses. And Sasha also mentioned this when he was talking, is that this does come at a cost, though. You do need a little bit of engineering expertise for this to work. So very, very, very small teams, it's very hard to operationalize this kind of architecture. You want to unlock that capability as you move forward and progress and mature, not only technically, but also as a business, especially as maybe revenue is shifting, customer changes are happening, etc. But at the end of the day, we do have, this is an example of a client architecture that we have. You'll notice the focus really isn't on the logos or the tech stacks, even though I pasted them on there on top of this diagram. It's really around data domains and data flows, which is what Stefan mentioned. So you're looking at where does customer data go? Where is it defined? Where is it referenced? Where is it used? Product, price, inventory, tax, shipping, all the different data domains. We often look at these things to say, where is this data defined and where is it going to go? And then layer in technology after that, not the opposite, which is how you get into like black box scenarios. So it's really all intentional. And when you do organize around data and through our implementations, we do focus a lot around where data lives and thrives because in B2B commerce, half the battle is making sure you create an informed customer. How do you do that? It's with data, not just fancy or fast websites. It's got to be around data. So as you look at more data, you're really looking at this based upon data and not vendors. And that's how you keep that ownership and those boundaries defined well. Because again, like that Boeing diagram where there's physical kind of boundaries, data is often your intangible boundary. So on the next slide, Oleg, this will be another example of someone who has a very composable architecture, and Virto is a part of that. But you notice here, Virto isn't a core pillar of it. It's just in the stream of data to enable this composability. And frankly, I personally believe, and I think all of us would agree on this call, is I don't think building things isn't the hard part anymore. It's really changing. And that's where decomposability comes in. So it lets us build systems that can evolve instead of doing a very, very big bang replatform every 3 to 5 years. So decomposability allows us to change and not necessarily refactor and build everything over and over and over as a project versus a product as a company. And this is just another example that you see here of someone who has done that and does have the team and business to support this, but they didn't get to this diagram from this webinar to tomorrow. It's taken years. It's taken years to get to this point in maturity all along. This did start as a monolith, as Sasha kind of alluded to, and it matures over the course of time. And that's just a good progression of how this stuff typically works.
Yeah, monolith is easier initially, but it can get incredibly hard to change if it's not the right approach. So yeah.
Yeah, you notice in this diagram, all these are obviously the gray boxes. All these logos, because of the composable architecture, whether it's the contract ending, maybe the provider isn't meeting the needs or demands on their product roadmap of the client, can be changed out. And it doesn't feel like a scary project to do that. It's just you sign a new agreement and you move forward and you replace one thing with another. And in a perfect scenario, you meet status quo and parity of what you're doing today, but what you're doing is unlocking a new ceiling of business capabilities to move forward. Doing things just to do things is an interesting way to spend time and money. Hopefully you're getting some business value out of those things.
Yeah, maybe just Jacobi, just maybe summarize what is the business value for choosing the different components, different systems for one solutions from business point of view. If you present it for some, I don't know, like on pre-sale activities, what you can highlight, why you choose the systems, what is the value from it?
Yeah, great question. So I'll use this exact example. There's some little icons on here with some very, very small green stars. Those very small green stars are business value icons that we're using here. So, a lot of the clients we work with, they don't generally come to us and say, "Hey, this platform is terrible. I want to move to a new one." They're generally coming across with, "I'm running into these issues as a business, and my customers want to do something else. What can support that?" And so, in this case, with this kind of architecture, this is a D2C company that's a retailer that has physical stores as well as the online store. And they wanted their site to be faster because in D2C, that's often, fast websites are necessary. And an edge native composable headless architecture allowed them to have more client side rendering as well as incremental static rendering going on. So in this architecture, not everything was server side rendered, which tends to slow things down a little bit in some cases. Things need to be pulled up to the client end to enable faster client side performance. And I know it sounds silly, but even a half-second speed increase does increase conversions for D2C in a lot of ways. And so that's where the business value comes in, Oleg. It's not, "Hey, let's move to a composable architecture just because it's fun and the new sexy thing." It comes from a problem statement or an opportunity statement of the business backed by solutions. I think a lot of organizations chase solutions without a problem or an opportunity identified. And that's where we want to start, though, is the business side.
Yeah, architecture should not be the goal. It's the business solution should be the goal. Yeah, solving actual problems. There tend to be some teams that are very focused on building this pretty composable architecture, like it is described in the book of some kind.
Yes.
And they lose the value of what's the meaning of it, why you're actually doing it. And often, more than often, it's actually certain elements are better not being composable initially. Only some elements are.
It's a tough challenge though for an engineering team. It's a tough challenge because just because you can do everything doesn't mean you should do everything. Saying no is half the battle of, staying busy is one thing, but providing value is another. And I think that's often the challenge for organizations is when you're given the opportunity to change so many of these quote unquote Lego blocks, doesn't mean you have to. Okay, doesn't mean you have to.
It reminds me of the whole approach of microservices, where there was at some point there was this whole idea everything should be microservice developed everywhere, and then it ran into operational nightmare where you have so many of them and you don't know how to test, how to integrate them, and so on.
Yeah.
So,
there should be
more things end up being broken than working sometimes. So
there
Stefan?
should be a
please.
purpose in the elements that you add into your landscape.
Yeah, it should be purpose and business value, right? So it's by different reasons.
Definitely.
Yeah, thank you. So it's Jacobi, Stefan, Sasha. So it's very valuable input. So let maybe step in me. And here's another practical example from my real client project. Let me explain the problem. So we have requirements from the client to provide a single window to all data. For example, allow customer to view shopping cart, order history across the multiple regions with high performance and low latency. And also include the Chinese as well with own regulation rules, global firewall, and etc. And in traditional setup, if hosting doesn't support composability, we would have to rebuild all elements of the ecosystem again and again for every region. Then configure and complex data synchronization where we need to handle conflicts, try to resolve it, and the system solutions will become quickly difficult to support and so expensive. But if you look on the composability, not from the architecture, and as Stefan and Jacobi said, from data flow and communication, look on the infrastructure, and the infrastructure supported, you can put and replace, use the same principles, replace the functionality, and like on the schema one, you can create green zone for fast and read-only replicated data access. you have a red zone with controlled data modifications. So the only element you see it's related the data flow and access to the data from database, but in infrastructure hosting supported by is the nature. And also, if you're talking about Chinese in orange zone, so it's with local hosting and regulation. So it allows to do it, they mix the data, get access, synchronize it, and etc. So you focus and you're talking with hosting and don't change any modifications on the product level. So it's on the data flow and etc. You recompose it. And it's just demonstration how the same principles can be applied on different levels of the implementation, solution implementation. In other scenarios, it's maybe also complicated, but you look on this one from another angle, from feature development. We had a case study when global organization has global team and local team. And a local team usually often must wait for global team to deliver changes. This slow down innovations and frustrate regional marketing and sales teams because they want to push something. And if you look on the schema, you will see like we decompose and roadmap delivery between global team and local team. So global team develops core functionality like loyalty program, global feature 1, global feature 2, and focus on it. At the same time, local team can work and start to implement using the same principles, modules, architecture principles, and etc. Start to develop it and customize payment methods, like you see it's in Europe, payments methods deployed and delivery, in Japan payment methods. But also you can see in China, if they have some requirements to implement some global feature, but faster, they can do it by themselves. Implement delivery, of course, synchronize requirements with global team, but they can test it, verify it, and deliver back to the loyalty team, to global team with feedback, with informations, with how they use it. And one day, when global loyalty program was developed, the replacement allowed to uninstall the local loyalty program and install global loyalty program module. So then replace it. Another example, what we see, it also brings the culture of contribution. Local team can implement something, test it, verify it, and then if it works, can work for another regions, for another companies. So again, submit these components on the global level. And after it will be accessible for and share it back as reusable components with other local teams in development. Let me just repeat it, though, example of how composable architecture can independently build original feature faster and same keep the same one architecture, minimize the creation of technical debt, minimize duplication effort, and open the door for marketing and sales team, for business team, going faster, test idea, right? And don't wait for global implementation for years.
So this is the real client with over, I think it's 30 different countries that they deploy with. And it allowed each region or country to actually have their own SIs develop features for them for their particular deployment of their solution, while still getting the features that the global team developed. If they need to, they actually can activate them. So they create kind of like a marketplace of features, and they get pushed from both from the top global team and your regional local teams. So local teams develop the feature, then they have their own kind of synchronization meetings. They say, oh, this feature is really used by our client. All other countries then see it, and then if they decide, they can take that feature, and then it becomes more of the global feature. And the same goes from the other side, where a global feature team will present, oh, we developed this feature, do you want to activate it? And they activate it locally. So it's the whole kind of marketplace of these capabilities. And it's allows basically certain countries move faster if they want to invest into digital more. Other countries can invest in different part of the business if they want to. Basically gives that flexibility for them.
Yeah, thank you, Sasha. Indeed. Okay, let me close the second part of the sections and going to maybe more interesting one, what we have today, AR. And before to it, just for fun, let me present you these two images. I asked ChatGPT to create visuals and ask them. Show me why composability matter for AI. And here you can see on the screen, here's the result. And let me read ChatGPT response. So on the left, you can see that I, as AI agent on a monolithic application. Think of this complex machine as a massive, huge box of wires where everything is interconnected. You ask me, AI means in here, for example, optimize the checkout process. And ChatGPT dives in because it's one monolithic application. Now, look at the right. It is composable world. Here, the system is built from well-defined independent block. Each block has clear purpose and interface. When you introduce me here, you can direct me with precision. You can say, ChatGPT optimize the specific blocks for payments processing. And I have a clear, bounded sandbox to play it. So it's all content AI generated. So it's no input from my side, just ask the questions to generate it and etc. So it's, and let me revert back after the slides word to our expert, Stefan. From your point of view, why composability matter for AI during the client project implementation? How you see it? What was changed in this year and how you see it will change the implementation of the client project in next year?
Yeah, definitely. Now, first of all, it's good to notice AI is here and it's not going anywhere. So we have to follow it and see where it brings us. But what we're currently in is we're in a world where a single purpose AI modules are being tracked by new composable networks of collaborative agents. It's just like the human brain, just like humans. AI struggles when contexts become too large or the problem is too complex. So to solve the real world challenges, the problems need to be broken up, distributed, and recomposed, making composable principles not just relevant, but very essential when it comes to the future of AI. Because in the next area, we won't rely anymore on one big giant model trying to do everything. Instead, we will be orchestrating a constellation of specialized AI agents, each with their own strength, each with their own data, exchanging data, and making autonomous decisions. These agents will also be able to innovate and optimize and collaborate in ways that could resemble high-performance teams. The future of AI is definitely not monolithic, but we have a big advantage when it comes to the involvement of AI, regardless to our own involvement. Our brain has different compartments that interact together to fix a problem, but they cannot scale infinite. And when it comes to AI, the different agents, the different techniques that can work together to solve problems, when addressing that in a composable way, we can scale it to extreme limits, making it a more open ecosystem, smarter when for every component that we add to it. So the future of AI, from our perspective, it's definitely not monolithic. It's modular, distributed, definitely composable, more like a living network of agents that grow, adapt, and advance together for end customers, but also for developers who are working with it. So maybe you can go to the next slide, Oleg.
Before to go to the next slide,
Yeah.
Sasha, do you want to add something related, maybe from platform point of view, how you see it, what it can be different, or if you see on the Virto Commerce platform and how it will apply the some implementations inside?
Definitely, there is a lot of to add here. One of the things that I know it's mentioned in slide that it's open source is a very important component of AI enablement. Basically, it's the source of truth for the logic that is within platform. So it's better for AI to read that actual source code than it is to go to the documentation on how it's supposed to work. So it helps the AI to understand what your systems are. And the approaches that you saw, atomic architecture, it actually falls quite well into the whole concept of putting guardrails on the AI. It basically tells you, you're working with the boundary of pricing list. I don't want you to think about anything else. You're thinking about how optimizing the price list. You have interfaces, you have APIs, you have a data constraint. This is the amount of data you have. Work with that and make it, work for my business. Creating new rules, whatever it is. So it's the same as a human. Why it's actually possible for developers to be very productive with Virto Commerce, because they also work with those constraints. They go and they don't have to understand the whole application. They just have to understand this particular module, this particular capability to make contributions. It's the same with AI. It only has to understand this particular part to make contribution, to make a better code. And from my perspective, in the future, AI will generate probably most of the code, while developers will control it. They will write the test. They make sure the inputs, outputs are correct. But it will be almost impossible to review what AI wrote inside, because it will be, tens of thousands of lines of code. You'll spend too much time reviewing it. You just need to make sure it follows the right architecture, so that code can be checked with other methods like tests and so on, and automation, things like that.
Yeah, thank you. Stefan? Yeah, please continue.
Yeah, thanks for the add-on, Sasha. If you look to AI will definitely reshape the world and have impact on every level. For example, if you look to the infrastructure level, what we're already seeing, that systems will become self-managed, scalable, adaptive. We don't have to control all the slides anymore. The boundaries and all the given data will control the slides and be even more efficient than we are at that level. Also at code-based level, development will shift, like Sancha said, from writing logic to orchestrating intelligent components. Open source will be a big driver in that. And at an experience level, AI will redefine how people interact with technology. More intuitive, more controversial. It will be more human. So our digital experiences will evolve dramatically. Touch points that we know now will shift. Blending across devices, channels, and context. Will we still search information the way we do now in the next coming 10 years? Where will be the truth of certain information? Also, the learning curve will drop drastically as interactions become more guided, more predictive, and more personalized. It will only get easier from here when it comes to AI and using AI in your ecosystem. Yeah, and of course, the prompting part of it will mature into a natural skill, moving from inputs that craft prompts to more like collaboration with intelligence. The more agents that are connected and have information about certain areas of expertise, the more they can be an advisor or an assistant to you, and also trigger new parts of creativity where implementations or certain experiences can go. But none of this all works. And then we're coming back to the same as I started with composable architecture. None of this works without data. Also for AI, data is more than fuel. It's the source of understanding how AI should reason, and also what kind of decision-making processes there are in the line. Without reliable, structured, and accessible data, there is no knowledge. And without knowledge, there is no AI. So the future of AI from our perspective is that it's definitely composable. It should be autonomous and at least interconnected. And the organization that masters their data will be the ones who's taking the lead in this competitive business.
Mm-hmm. Stefan,
Yeah,
so I know that
the AI itself is about knowledge automation. I mean, that's what I think Gartner is saying. It's now we're not the factory automation, but the knowledge automation. So you're automating like the concept that we before were not able to do. So data is very important.
Yeah, Stefan, maybe one or two examples. I know that you already create a lot of AI modules. Where you see that can be top 2 or top 3 modules that you will share and recommend to use your customers?
Yeah, there are There are multiple ways where we already integrated AI possibilities within our ecosystem of B2B commerce. The first of all is we extended Virto itself with an AI layer where we can translate, create product description, images, all the normal things that everybody does with AI, but then integrated within Virto. We also made that agnostic. So you can use OpenAI, you can use Microsoft, you can use Gemini. No Grok implementation there, maybe in the future it will, but there are multiple ways in really adding and giving the maintainer of the whole commercial stack interactions with the AI modules. And the second part is that we're interacting with partners that can make certain areas more interesting for our customers. For example, I gave the example before. We have a customer where we're integrating all their analytics data together with all their commerce data and the current profile of the visitor that's within their e-commerce environment. And we integrated that with Virto Commerce. So the proposition that an end user sees within their portal is completely fit on how they're using the portal and can also be fit in what's trending in a certain area or a certain country. Or if you have extra stock, which country can offload that stock more easily. So there we're really combining customer data, product data, and commerce data together to give a kind of personal experience to the end user. And that external supplier that we're using to provide all the data and integrate with has an AI lake that's going to train with their algorithms to make that experience better and better. So next to direct integration with persons to extend functionality, we also integrate with third parties to extend experiences for end users. But a lot is happening on this part, to be honest. Yeah.
Yeah, I agree. Okay.
So, and this was, and already Sasha told something about this part. It's more like from the developer perspective, when you're a builder, when you want to develop, for example, on Virto Commerce, one of the main drivers of AI within software development will be the open source nature of the project, like Sasha already told us. Then you can really train the module in how it was built, what is the DNA of the module of the implementation, what choices were made, but also where can we extend it. So as a developer, you could, or business consultant even, you can ask these specialized assistants, okay, we want to have a custom implementation on real-time pricing in combination with the Microsoft D365 ERP. The system can look what's already in place. The system can look what was already built by us as composable components. They can evaluate if it's a fit for the current customer, and if not, it can advise where we can improve this module to facilitate what the customer needs. So AI will be a real direct personal assistant when you can train it with your code. And what's also important is when you're using open source, it becomes an engine of innovation. It's also enables rapid iteration, but most important, community-driven breakthroughs. Other people and other systems see other things that you see, maybe on the same implementation, on the same design, which can create to new creative outcomes, possibilities, expectations for end users. Yeah, and of course, what we're seeing nowadays is a lot is already automated. AI is really taking its turn on the development process. Advanced automation, repetitive tasks, code reviews, testing. Sasha already explained it previously, but at the end, it will lead to faster development cycles. AI agents will assist with feature implementations, documentation, debugging. The goal is reduce time to market for new functionalities. No solid roadmaps, but more experimental, doing things on the fly and see what delivers business or business value and which not. So there's a whole area and a whole future for us when it comes to AI.
Yeah, there is so as part of the platform, we add in a lot of, in our modules, we add in LM instructions inside the module. So when you open that module with an AI context, it actually uses that information because it describes, this is how it's architecture, this is the purpose. So it doesn't have to go through the whole code to understand it. We give them, here's the best practice, here's how you extend it, so you don't have to do all that.
Yeah.
And it's been a tremendous kind of booster to productivity for us as well.
Yeah. The whole open source fuels the intelligence what you want. The AI agents provide you the speed and the infrastructure to do it, and together they can redefine what modern software development can be. And we're at the controls, but it's going rapidly, so it's good to stay on track on that part.
And
Yeah,
anecdotally, you know, this is interesting. So Oleg, you had those two ChatGPT generated diagrams. And we've been using GitHub Enterprise here at Luminos Labs to help us move faster. And I will say, you know, there are some platforms or technologies that are more that monolithic approach. And our acceptance rates of accepting the code that it generates with Copilot with those platforms, I literally just looked as you guys were talking, is about 12% over the last 28 days. Now, if we look at something on Virto, our acceptance rates of code because of the composability, the module side of it, is 29.63%. Pretty good. Now, there's a lot of variables in there, but one thing that is telling is if you have more of a black boxed approach, you're not putting your chances of success is very high because the context that it can read into is not that great. When things are more open or more open source, you're getting a higher chance of success because it has better context. Now, the prompt engineering does need to be good. That's a skill set in and of its own that folks, you know, will be learning more and more about. But I think that's one of the barriers is if you've not gone through a composable architecture as we progress through this AI area, I think you're kind of setting yourself up for stumbling because you have to catch up at some point. There's some questions in the chat regarding that. I'm trying not to answer, but I think this is one of those things as technology progresses, and if you've stood still, the gap gets bigger and bigger. Okay, but Stefan, you're right. There's a lot of pieces of the client idea to production lifecycle that you can apply AI, whether it's design, code, BA work, PM work, etc. It's all applicable.
Yeah.
And it looks like, from my point of view, how we eliminate and automate some process. So from the business point of view, it will look, we have idea, and count of the human activities will be decreased. So we will minimize. Of course, we will control it on top of it, but the duration of the implementation will increase, and we can deliver the functionality in the right way to business faster. So that's how I see it, how you understood, just to summarize.
And it's there was an intention in our design of the platform that we allowed as much extensibility to the modules as possible. We went basically a different way compared to traditional SaaS platforms, where they put guardrails right away. You can only integrate through this API, through this webhook. In our way, you can, you know, replace the whole functionality, the whole components, and so on. And our bet was, of course, when you do that, the ability to upgrade to a new version becomes a problem because you might modify too much. What we bet on is that the AI tools will come where they would allow you to actually improve that updatability and process, actually automate it. You don't have to worry about it. But with that, now it's actually possible to do that. You can almost automatically upgrade the platform. You can check what were the changes and how do you need to update your implementation to accommodate those changes. It become a very seamless process with just few prompts. We now have clients who update in a matter of days the solutions that have been built, 3-4 years ago. That was not possible before. With AI, you actually can do that. And that gives you kind of this, very big edge against, this very guardrailed SaaS systems that typically are there, that prevents you from utilizing new technologies, let's say. There is all sorts of new kind of hosting, composability, and so on. So that's, I think I wanted to make that kind of topic there.
Yeah, agree. Okay, so it's maybe, unless I'm mistaken, we already summarize our vision of AI and explain it. So let me maybe Jacobi, reverted this final slide, and then we go to QA. Let me pass to you. So we started with core principles like what we were before, IT and e-commerce air, and what we have today, and how it match. So please present your vision.
These are if we circle back to the Boeing airplane again, and if we're talking layman's terms, this is where it all comes full circle. So we started with planes, factories, and machines. The boundaries and the feedback were physical in nature. Then we went digital. We lost that boundary. And I think we've all collectively, as technical folks, have spent the last 20 years earning that back of understanding where our boundaries are regarding data. And now AI shows up and it's accessible by everyone, and suddenly everyone acts like the laws of physics don't really apply again. But the same principles are holding. So obviously these aren't new ideas. They're the same rules that kept airplanes in the air or the lights on in your house. But I do think that we have to think about composability beyond the technical interfaces and applying both that human-centric organizational discipline that I mentioned and treating data as your new version of oil, gas, water, oxygen, whatever it is flowing through the system or platform you're talking about to be set up for success. Now, the longer you ignore these principles and the organizational discipline, I think that gap that I showed with those arrows crossing gets bigger and bigger. I think at some point you do have to course correct, and that can come across as a hard left or right turn. But as our technical capabilities using AI continue to increase, our ability to use them needs to at the same pace. Otherwise, we'll stumble. And so it's just another progression on that chart that I had shown in that previous slide.
Yeah, thank you. It's a good summary for this session. And going to the QA, and what I see in the chat at primary first questions related, if companies stuck on the older monolithic system, what is a really realistic, low stress way to start introducing new composability e-commerce system or another system without, let me say like this, burning or destroying or rebuilding the current system or destroying business maybe as well. So Stefan and Jacobi, I think it's primary question to you. How you see it? What is the way of the working for this kind of companies? Stefan?
Stefan, go ahead.
Yeah, I did not understand. Can I read the question somewhere? Sorry, I did not really understand it very well.
Yeah. If company already use monolithic system, what is the way to migrate, right? And with low stress, right, to new system, to new composable architecture without destroying the business at all.
Now, moving to a composable system, of course, is not something you take very lightly. It's not something you can start it up separately next to your next system, of course, with your production, keep the production up and running and try to figure out how to start with an implementation partner to getting the composable system up and running. But there are some certain steps which you can take in there as an account. First of all, you have to understand that you have to move to an ecosystem because the world is changing, data is changing, suppliers are changing, and with a monolith system, you will get behind when you look into the future. So you have to very good know what your domain module is. So what kind of enterprise are you working in? Are you talking about products, customers, orders, prices, inventory, multi-channel suppliers? Where does that fit in your whole architecture? And how does that currently being processed in your monolith to see where are the lines and which components can be reused even from a monolith approach? Also very important, you need to know your data master management, your golden records, decide who owns what is your golden record and what are the touch points of that. Mostly that's a little bit hidden within monolith systems because the record is mostly defined by the system that you're currently using there. But you have to step out and say, okay, this is the data that I have. These separations of concerns I want to put on my data. So I want to put my product data closely in a PIM. I want to put my marketing data, etc., etc. You have to define which areas of expertise, areas of concerns there are really on. You also have to think about which of those parts are global identifiers. So what's important through my whole ecosystem, which parts am I only designing once and want to reuse on every different level? My main switches where I can turn things on and off. And you have to look in all the systems that you currently have, if they have a kind of contract first API. Is it possible to get the information there to really build composable systems? So you have to step out of the system that you're having. If you have a monolith system, you have to bring it back to the real world. What is your business? Which areas of expertise are there? And how do they interconnect if I want to put them into an ecosystem and think out of the box? So that would be the kind of approach, Oleg.
If I were to answer that really quickly, and Sama, I think that was you with the question. Thanks for that. If you truly do have a true monolith, okay, and I'm talking a true monolith where it's all black box, sometimes, quite frankly, the answer is scorched earth. Okay, sometimes you do have to go scorched earth on the thing to make a step in the right direction. But more than likely, you're running a modular monolith, meaning you can use a strangler pattern to slowly siphon off those services to get you to that ecosystem and Valhalla, that Stefan's mentioning. But that's more than likely the case. Unless you haven't done anything for a very, very long time, usually a lot of things are built as a modular monolith, meaning you can break off pieces to where suddenly the core becomes decentralized. And again, that doesn't happen just from one day to another. That's over the course of time, like I'd shown on some of those diagrams. But sometimes, truthfully, it is scorched earth, and it's one of those hold your breath big project to get you to that ecosystem. I'm not going to lie. Depends on how hesitant you've been in the past historically.
True.
Yeah. And maybe a final question for the session. So, Sasha, to you, what is the way and what companies should fix in the architecture today to prepare for AI-driven automation? What
I mean,
companies should fix?
I always prefer to look at the problems from the kind of the business perspective, where your business, your specific business, can take advantage of AI tools. If you're a B2B business, it can be maybe you get slammed by too many custom purchase order requests that you have to, you have a whole staff that have to sift through, and maybe you're losing some business because you miss some of the important requests or you're not replying in certain time. So if that's the case, maybe you should, figure out how you should prepare that part of the system for automation. And you can do it almost immediately. I mean, if your requests are going through emails, you can automate that part right now. There are plenty of tools that actually do that. But again, it's kind of depends on your business. Where do you see the most kind of bang for your buck in your system? What can you automate? Where you spend the most time? As I listened to one of the recent talks about AI, it's actually cruel to make humans do the repetitive work that can be automated by AI. And they actually named it as inhumane. That's what, if you're making someone doing automated work, it's inhumane to do that. They shouldn't be doing that work. So that's probably what I think you should automate and prepare. And then, elevate that person to do more thoughtful things, not the robotic things that, you can automate.
Yeah, it looks like a new way of the working in AI brings a more business-oriented, right, architecture, more person-oriented for specific sales reps, marketers, right, and category managers, except for another one, and focus on the productivity and improve it without. Of course, we need to keep technical implementation architecture behind, but it's shifted more to business value and business decision because it's can be delivered and tested and verified faster. So what I see, so it's, we're out of the time. So thank you everyone for the sessions. Thank you, Sasha, Stefan, Jacobi. I think it was interesting talk about it. And if you would like to more, we are available to discuss next steps. Contact already shared in the chat. And I hope this discussion helped you, and we will see you on the next discussion soon. Thank you very much.
Thank
Thank you,
you.
everyone.
Thank you all.
Bye-bye.